So this is very similar. They're not giving us a wall though, so we have to do all four sides with the fencing. Did they say 80 meters on this one?
Yeah.
Fencing? Okay, so if we have 80 meters to go all the way around, and we call the widths X, what could we call the lengths?
Y.
No. Remember what we did last time?
X minus
80 minus.
Okay, we have 80 meters to go all the way around, but if we've already used X here and here, that leaves 80 minus 2X. However, what's wrong with this? There's two sides. So this needs to be split in half. Listen. This is what's left for both of these. So how do I split it up? Right, divide by 2. So divide by 2 is like 40 minus X. For those. We probably don't need to write it twice, but that's okay. This is number 2, by the way. Not number 3. What are the questions? What's the maximum area? So how do I find the X value? All right. What's the area function for this situation? Base times height. So 40 minus X times X. Or if we multiplied it out, negative X squared plus 40X. Why do you guys just assume it's Grant? That could have been Eli.
No, it's not. It was not Eli.
That's racist to just make assumptions like that.
What do you like?
But we're all
It's
the same
correct.
race.
It's correct when we make assumptions like that.
I said this every time we did something.
It's grantist to make assumptions like that. All right, how do we, so it's a negative X squared, so that means it would be just like the last thing, it would be a upside down parabola. So how do we find the maximum area? Negative b over 2a. That is to help us find, or basically we're looking for the vertex. Because that tells us the maximum area. Negative b over 2a tells us what the width that gives us the maximum area is. And then we plug in that x value. Well, we can plug it in here and multiply, or we can, which is the same thing as plugging it in here and multiplying. So, yeah, you guys get it?
Yeah.
So, negative b over 2a. That's the x value that maximizes, which is what? 20. Okay, now let's think about this. If there's 80 meters of fencing and x is 20, what would this be? 20. So what kind of rectangle is this? It's a square. So what they're saying is, if you're making a fence and you want to maximize the area, what shape should you make it? A square. Now it was different on the first one because it gave us a wall. Somehow that changed the answer. I don't completely get it, to be honest, but that's how it works. Anyways, yeah. So it's a 20 by 20 square, so what is the area?
400.
Yeah, 400 square meters.
That's a small box. Wait. That's 4 meters. That's
20 meters by 20 meters would be about almost these 4 classrooms combined.
Centimeters. It's like small.
Yeah, centimeters are tiny. He's just a little guy. Numero 3. for some reason on the odds they drew the picture for us. On the evens they did not. Because it's amusing.
They hate us because they ain't us.
Yeah.
They wait for the service,
What's wrong?
I don't know what to do with it.
2?
I need.
Okay, number 3. Suppose you have 102 meters of fencing to make 2 side-by-side rectangular enclosures as shown. So it looks like we got a wall again, do we? No, we don't have a wall. Never mind. So 2 side-by-side fences. Okay, if this is X, what's this? So what would that leave for, okay, fencing is 102 meters. So what would that leave for this side?
102 minus 3x.
Well, except for that would have to be shared between these 2 sides. So I'd have to split this in half. You could do 51 minus 1.5x, or you could just leave it like that. Probably easier to do 51 minus 1.5x. All right. Now we're probably going to ask us the same questions. Suppose, okay, what is the maximum area? So the same as number 2. Okay, so let's write an area function first. What is the area of this going to be? Base times height. We don't really need to find these 2 separately because this area plus this area will equal the total area. So base times height, or if I distribute it, put it in standard form, it's that. Okay, so it's an upside down parabola. How do I find the vertex of this parabola? Negative b over 2a. This kind of comes from the front of the quadratic formula. That might help you remember it better. Oops. This part of the quadratic formula. Anyway, it tells where the null graph is. So negative b over 2a is 17. Okay, what does 17 tell us? That tells us the best width to use, 17 meters, for these. But if the question is, that's not the question. The question is, what is the best area we can get? And yeah, we would plug in 17 into this, or this, same thing. So 17, I don't think I can do that in my head. And that would give us the max area. You have something to say, Hope? That's right, you did. It's because it was threatening. Yeah, you call me an old man, guess what's
You call
coming?
me an old woman. I'm not old.
But you're like really old.
No.
Dinosaur age.
Especially at somebody's grand age, it probably seems.
Throwing a shout out in the history books.
Nah.
She's only a fruit, bro. She's gonna be She's gonna vote for
I don't
Lana
know.
because she doesn't like
You're gonna be 1 month short of being able to vote, though.
Hey guys, I was gonna go. I'm
I have to
She's
wait
gonna
for
vote
3
for
more
Harris.
Yeah.
years.
Okay, did anybody plug that in? You're just standing there doing nothing.
Yeah, you have to wait 3 years.
That's
So,
so
or 4 years.
Oh, it
Like,
did.
you can't, no, it's one.
How
You
would you-
can't, no, it's one point.
Dude, you know how to do that.
Okay, should I just leave number 4 to you guys? Suppose you have to use exactly 200 meters fencing. Okay, fine.
We should just stop at 4.
Suppose you have to use exactly 200 meters of fencing to make either one square enclosure or 2 separate square enclosures of any size you wish. What plan gives you the least area? So you can make one giant square or 2 squares of varying size. Which plan gives you the most area? Which one do you think is gonna be, guys?
Big one.
Yeah, because on this one you're kind of wasting a lot of fence just trying to make 2 squares. Anyways, yeah, I think it's gonna be the big one. Let's see, what's it say? 200 meters. So on the big fence, the big square, if it's 200 meters of fencing, what's each side gonna be?
200 divided by 4.
Right, 50. So what's the area of the big fence, big square gonna be? 50 times 50. Couple of zeros on that one, 0, 0. 2,500 square meters of fencing.
That's the answer.
No,
Oh.
that is how much the big fencing would be. Okay, so on this other situation, let's say this square, let's say is x by x. So how much fencing have we used on this square?
4.
4x. Okay, how much fencing does that leave for this square?
0.
200 minus 4x. Okay, but we want just one of the sides of the square, so this is how much is left for the whole square. So how would we get just one side of the square? Divide by 4. So that would be 50 minus x. Yes, like the one on the test is, I don't remember for sure, but I think it's like number 1 or 2.
You're scaring me, Mr. I almost said Mr. Frederick.
What if,
That's what the freshmen call me that.
if you don't put it on the test? Wait.
Too late. Okay, so how do I find the combined areas of these two? What's the area of this guy?
X 4, 2.
What's the area of this guy?
5, 2.
Okay, this would be a FOIL problem, right? So it'd be x squared minus 50x minus 50x, right? Plus 2,500. And if I add the two areas together, what do I get? The total area formula, 2x squared, because we're adding, not multiplying. 2x squared minus 100x plus 2,500. And we're gonna want to maximize this area. Okay, actually,
You can take 2 out.
this one's different because, but guys, stop. It's a positive 2x squared, which means the higher areas are actually going to be when like x is 0. Okay, now if x is 0, what does that mean on this problem? That means like this square would be gone and you just have one giant square. So basically the big square would be the best. Which is what we guessed at the beginning. This would be if x is 50, because 50 is as big as this could get. And that would also make this square disappear. So the maximum area is actually, it'd probably look more like this. When one of the squares disappears. When x is 0, when x is 50, one of the little squares disappears. Did they ask? What did they ask? How did they ask this? I can't forgot. I suppose, what plan gives you the least area?
The small square.
Yeah, let's see, they put, okay, so the least area would be right here. So you'd use negative b over 2a to find the least area. And that would be 100 over 4. So, which of course is between 50 and, so when x is 25 meters, that would make these two squares like identical, and that would actually be the least efficient. Two small identical squares. And the best plan is one large and the most area, one large square, 50 by 50 square.
Can I draw a square instead of writing square?
Why?
Because one's 4 lines and one is 1, 2, 3, 4, 5 lines. Oh,
So stupid.
We'll go over this again a couple times before the test, so by the time we get there, I don't think you guys will be too intimidated by this. Is it kind of making sense though?
no.
Too bad. Okay. Number 9. Yeah, number 9. Next. Alright. No. Physics. If a ball is thrown vertically upward at 30 meters a second, then its approximate height in meters t seconds later is given by h of t equals 30t minus 5t squared. Okay, let's try to figure out what they just said. Okay, what do you guys think t stands for? Time. What kind of time? Seconds. What do you think h stands for? Height. So this formula is to give us the height of the ball. What would this look like t seconds after you threw it? What would this look like if we graphed it? Parabola upside down. If the t squared is negative, t squared is stronger than this, so it doesn't matter if this is positive or not. And what's happening at 0, at t equals 0? Huh? What's happening at t equals 0?
No. 0.
If you plug in 0, what do you get? 0. So at 0 seconds, the ball is 0 feet off the ground. Is this feet or meters? I kind of forgot. Meters. 0 meters off the ground. So now technically, if somebody's going to throw the ball, they're probably holding it not on the ground, but you guys get the idea. When somebody's throwing the ball, it's probably like a meter off the ground to start with. But anyway, that kind of gives you an
Do
idea.
we need to draw the graph or?
No, they didn't ask for it, but the graph is kind of important to understand. Okay, now, so if it's a parabola upside down, it's going to look like this. What does this point over here represent?
Where?
No.
T minus
T represents the time in seconds that are passing. H of T is replacing the Y value, so it represents the height of the ball. Okay, so what does this point right here represent
What it wins.
when the ball hits the ground? Now, do these lines down here make sense on this problem?
No.
No. And this would be like negative time. It's not gonna go below the ground, okay? Like a ball that pierces the earth. Okay, now, when you actually throw a ball up in the air, it doesn't go like this, it just goes up and down. So this is not an exact picture of what the ball is doing. It's, over time, this is the height of the ball. That makes sense. We're not like throwing the ball out that way. I just did a girl throw.
Oh, that's
True.
Well, I had this foot planted. You're supposed to step with the left and then throw with the right.
yeah, well, I
Are
do.
you a pro thrower, Mr. Jordan?
I can throw. But no, I'm not a pro. Let's see. Okay, so this is when it's the ground. This would be the high point. Of course, that's the vertex. Let's see. All right, what questions is it asking? After how many seconds does the ball hit the ground? So what are we looking for?
The last one.
Okay, so we need the value of t that makes this function equal 0. Because when the height's at 0, when the ball's on the ground, the height's at 0. So basically we need the zeros of the function. We need the roots of the function. We need the height of the ball to be 0. So how are we going to solve this?
Take out 5.
Okay, we can factor or quadratic formula. Okay, we can take out a 5 and a t to factor. And if we divide this by 5t, we get 6. This divided by 5t is t. So what values of t make the height 0? 0,
And 6.
6.
Shut up, Baldy.
All right. So at 0 seconds, the ball is on the ground. Well, hadn't been thrown yet. At 6 seconds, the ball is going to be back to the ground. So guess how long before the ball gets to the high point?
6 seconds.
3 seconds.
Stupid.
Okay, now this question though, they ask, when's the ball back on the ground? So the answer would be 6 seconds.
Stupid. I didn't even say anything.
All right. B, what is the domain of H? So what x values, in this case they're t values, what t values actually make sense on this problem? We kind of already talked about this. 0 to 6. T is at least 0 seconds and at most 6 seconds. At 7 seconds, the ball is not going to go drill into the earth, so that doesn't make sense after that. Okay, C, how high does the ball go?
30 meters.
Okay, at 3 seconds, because we know it's going to be at the high point, the vertex, or if you weren't sure, you could do negative b over 2a and get 3. But 3 is how long until the ball's at its high point, because it's like halfway from getting back to the ground. But to find the high point, you'd have to plug in 3 seconds to find the height. So when t is 3, it should be at its highest. 3 times 3 is 9, 90. 3 squared times 5 is 45. 90 minus 45 is 45 meters. So we go 45 meters into the air.
Wait, what if you throw it faster than gravity?
Gravity doesn't have a speed.
Yeah, but what if you throw throw it, and then it goes down, but it doesn't reach the height.
Business.
Okay, this is based on if you throw it 30 meters a second to start with. Okay, if you threw it like 60 meters a second, like really hard, it would go farther, of course. So I'm guessing yeah. So they said if you throw it 30 meters a second, this is the formula that works for it. So maybe if you change it to 60 meters a second, this would change to 60. I don't know exactly how it works. This is kind of a physics question. Physics has to do with forces interacting upon each other.
Business.
I know. What is this?
What's going on?
Are you doing
Business. Okay, I'll just assign 10 for homework. Why don't you guys work on it for 10 minutes? See if you can crack it. It's kind of the same thing. It's a ball being thrown into the air.
So are we only going to 10?
Yeah. So one difference on 10 is that the ball is starting 30 meters on the top of a building. So what would that look like on the graph? Start up at 30 meters.
Can you scroll up on the last one?
Really, 5 of you?
It takes
We
a
need
lot.
5 people to understand it.
No, that's too many. Girls, you two need to move back.
We would not be needed.
Shelby and Willow.
Can we work in a group of two?
Good luck, guys.
Yeah.
Okay.
Are you working together?
I guess we have to start off with.
If 5 of you do it, that means like one person will probably do it and the rest of them.
Brandon, did you know did it together? Not really.
I guess maybe we start with.
Okay, I'm just gonna, I'm afraid to know what. Alright, so.
Is it the same thing as number 9?
Pretty close. One difference is they're starting on top of a building.
The volume's on.
H.
The next one's less than the third one is how high is the wall.
Okay, so this is where I'm stuck.
It goes pretty
So
high.
he said that it's like kind of.
Yeah, it's not studying.
You can still make it.
Well, I feel like barely went up. But like, it's faster this time, but it's slow.
Okay, we're just gonna, wait,